Hello everyone, my name is Keerthana S N. I am here to explain you about the lab program 6 of DDCO. The question goes like this. Design a Verilog program to implement different types of multiplexers like 2:1, 4:1 and 8:1. Now let us know what is a multiplexer. A multiplexer is a combination circuit that has two N input lines and a single output line, which means a multiplexer is a multi-input and single output combination circuit. Binary information is received from the input lines and directed to the output lines. On the basis of value of selection lines, one of these data input lines is connected to the output. This is an example of multiplexer. Here we have two selector lines S1 and S0, and input lines will be 2 power m, where n is equal to number of lines, so 2 power 2 is equal to 4. We are having 4 input lines and a single output line. S1, S0 and S1 will take the value 0, 0, 0, 1, 1, 0 or 1, 1. Inputs are fetched through the input lines and output will be obtained by the output line. Now let us see 2:1 multiplexer. Here S and D are inputs and Y is output. Here S is single bit selection input. It declares which of the two input is selected, and D is 2-bit data input. It represents possible values that can be selected based on value of selection input S. Output Y. It gives the output of multiplexer. The selected input is routed to this output. Register Y. It declares a register named Y which stores the output value, always at S or D. It specifies the logic inside should be triggered whenever there is a change in either the selection input or the data input D. Case statement. Case of S. This initiates a case statement based on the value of selection input S. If S is 0, then output is also 0. If S is 1, then the output Y is assigned the value of second data input D of 1. End case ends the case statement and module ends the module. Here is the output of 2:1 multiplexer. This is the Verilog program which represents 4:1 multiplexer. Input 1 is to 0 is. This is the 2-bit selection input. It determines which of the 4 input is selected. Input 3 is to 0. D. 4-bit data input. It represents possible values that can be selected based on the value of selection as output Y. Output of the multiplexer. Register Y. This declares register named Y which stores output value. Always block, always at S or D. This block specifies logic inside should be triggered whenever there is a change in either the selection input S or data input 0. Case statement. Case of X. This initiates a case statement based on the value of selection input S 0. Y is equal to D of 0. If S is 0, then the output Y is also assigned as the value of the first data input D of 0. 1. Y is equal to D of 1 specifies D of 1 is assigned to Y. Same goes to 2 and 3 as well. End of case, end of module. 8:1 multiplexer. Here there are 3 selector lines and 8 input lines and 1 output line. Input 2:0 is 3-bit selection input, which determines which of the 8 lines to be selected. Input 7:0D. 8-bit data input. This represents possible values that can be selected based on the value of selection input S. Output Y. Output of the multiplexer. Register Y declares the register named Y which stores the input value. Always block, always at S or D. This block specifies the logic inside should be triggered whenever there is a change in either the selection input S or the data input D. Case statement. Case of S. This initiates a case statement based on the value of selection input S 0. Y is equal to D of 0. If S is 0, then the D of 0 is assigned to Y and so on up to 7. End of case statement and end of module. This is the output of 8:1 multiplexer. Thank you.